For years, the void between stars has kept its secrets, a place beyond reach, beyond light, beyond comprehension. But now that silence has been broken once again, not by chance, not by accident, but by something deliberate, something hidden. An object, but not just any object. This one is different. It's distant, red, compact, and terrifyingly massive. And what's worse, it's rewriting the rules of the cosmos itself. The James Webb Space Telescope, piercing the infrared veil of the universe, has sounded the alarm. This isn't just another cosmic relic. It's an anomaly from the dawn of time, defying physics, quantum laws, and everything we hold as truth. And the data it reveals, its redshift, its luminosity, its impossible density, might be telling us something we're not ready to hear. Because what this object exposes about the universe may also be a harbinger of unraveling reality. When the first glimpses of ancient galaxies flickered into view in 2022, they stirred wonder across the scientific world. Then came the quasars in 2023, blazing, voracious, a handful of deep space enigmas, unexpected and unexplained. But then the cosmos grew cryptic again. For months, nothing pierced the ancient light barrier, until now. On a crisp January night, the James Webb Space Telescope's NIRCAM instrument detected something unusual, a faint red smudge in the direction of the Fornax constellation. At first it was just a dot, insignificant, maybe a distant starburst. But as more spectra poured in, astronomers realized the truth. This was no ordinary galaxy. It was at a redshift of 9 from when the universe was barely 500 million years old, on the edge of the observable cosmos. The name? Kuiper's LRD Z9, the most extreme little red dot ever found. And almost immediately, the warnings began. With a mass equivalent to billions of solar masses crammed into a space smaller than our galaxy's core, Kuiper's LRD Z9 is unlike anything we've seen before. It's not just existing in the past. It's challenging the present, with energy outputs that bend quantum mechanics to the breaking point. A cosmic fracture, pulsing brighter than theory allows, and yet we know almost nothing about what formed it or what it implies for our fragile existence. The James Webb Telescope, designed to unravel the universe's infancy, has joined a fleet of observatories in dissecting this terror, and what the data shows is unsettling. Kuiper's LRD Z9 is tiny, just a tenth the size of the Milky Way, yet it harbors a supermassive black hole at its heart, one that shouldn't exist so early. It emits a strange, reddened glow shrouded in gas and dust, rich in heavy elements that quantum models say couldn't have formed yet. But what truly horrified scientists was its power. From the cosmic dawn to now, its light has traveled 13 billion years, and its spectrum spikes with emissions that defy the standard model. That's no quiescent void. It's active, ravenous, and it's ancient. Based on growth simulations, Kuiper's LRD Z9 may have seeded itself in the first 100 million years after the Big Bang. That's before stars ignited, before time as we know it stabilized. It could have been lurking in the quantum foam before the first black holes were theorized to merge, which raises a question that no one can yet answer. Why here? What force birthed it so massive, so soon, on a trajectory through time that pierces our understanding now? This is not the first time we've glimpsed an early universe anomaly, but a surge of little red dots in 2 years after eons of theoretical silence is no longer coincidence. Scientists are now asking whether this is the onset of a paradigm shift or the echo of a hidden quantum pattern. Each dot has been radically different. Some are star-packed, dense with population 3 relics. Others pulse with active nuclei, devouring gas like insatiable voids. Kuiper's LRD-Z9 is somewhere in between, black hole dominated but oddly compact. All appear at high redshifts, all show anomalous light curves, and all 300 challenge what we thought we knew about cosmic evolution. But here's the twist. These objects aren't just teaching us about the Big Bang's aftermath, they're unveiling something about our own quantum entanglement with the cosmos. Their masses, their formations, their defiance of time dilation. They all suggest the universe is more intertwined, more simulated than we ever imagined. And the more we observe them, the more it feels like reality itself is glitching. So where did Kuiper's LRD-Z9 come from? The clues lie in its spectrum and structure. Its extreme redshift points to a direct collapse from pristine gas clouds, bypassing star formation entirely, possibly triggered by quantum fluctuations in the early plasma. The object's ruby hue and intense emissions hint at a cocoon of ionized hydrogen, conditions that exist only in the universe's hottest, most chaotic epochs. But here's where it gets truly bizarre. Some researchers suggest that objects like Kuiper's LRD-Z9 might not be entirely natural, that perhaps they are artifacts, remnants of a prior cycle, maybe even engineered. A few even speculate, could these be signatures of simulation code? Glitches in a quantum computer vast as the multiverse, where black holes serve as data sinks, signals we cannot pass, structures that warp time itself. There's no proof, only anomalies. But James Webb is probing. And as this object's light fades into the cosmic microwave background, we have only a narrow window to decode it all. Because who knows how long before another emerges or what unraveling it might trigger. As Kuiper's LRD-Z9 was analyzed more closely, astronomers aimed to map its core. Using precision spectroscopy from the James Webb's MIRI instrument, they dissected its emission lines over time, hunting for variability. What they found added yet another layer of dread. The object accretes matter at a rate hyper-efficient, devouring gas clouds in hours, what should take millennia. But the real shock came from the gravitational lensing. It was uniform with minimal distortion across its halo, suggesting an unnaturally spherical event horizon. That's uncommon for black holes, which are typically warped by mergers and spins. Some have speculated that this perfection could hint at a primordial origin, untouched by cosmic turbulence for billions of years. Others whisper it may not be as organically formed as we assume. But what's most compelling is how much Kuiper's LRD-Z9 doesn't resemble its fellow dots. It accretes faster than the others. It's denser than predicted, and it's emitting quantum-entangled particles at rates that echo the Hawking radiation and paradox. These factors don't just make it strange, they make it existential, a singularity that shatters models and demands we confront the void within. As instruments scanned its emissions, researchers began hunting for indirect echoes, shifts in cosmic rays, anomalies in neutrino fluxes, and variations in dark energy densities. And in one dataset, buried in gravitational wave noise, they found something. A faint but relentless oscillation. It wasn't a burst in the conventional sense, no clear frequency, but a subtle ripple in the fabric of space-time. Every time Kuiper's LRD-9's spectrum aligned with nearby quasars, the background curvature twisted ever so slightly, as if the object was subtly influencing distant events. That could be due to its immense gravity, its gas outflows, or perhaps something else entirely. This ignited a storm of theories. Could it be leaking information from another dimension? Could it be enveloped in a quantum field of exotic matter or even wormhole threads? Or more dramatically, could it be a bridge to a simulated layer, reacting to observer effects in ways quantum mechanics forbids? Because the James Webb Telescope wasn't just observing Kuiper's LRDZ9. It was witnessing how the universe around it warped. And in those distortions, there was one conclusion few dared utter. Something about this object didn't just emerge from deep space. It defined it. After months of scrutiny, researchers began leveraging the discovery of Kuiper's LRDZ9 to revisit a core enigma in cosmology. How did black holes grow so vast so quickly? The estimates were modest, but this little red dot has forced a drastic overhaul. With hundreds appearing where none were expected, scientists now gauge the density of such anomalies at 1 per 10 cubic gigaparsecs. That's alarmingly abundant. It means the early universe teemed with monsters, making their scarcity later feel orchestrated. Hundreds in mere surveys, all defying timelines, all surfacing as our quantum telescopes matured enough to detect them. Is this mere cosmic serendipity, or are we embedded in a larger simulation where parameters tweak to reveal flaws? A quantum rhythm pulsing on scales beyond comprehension. Maybe these aren't just relics. Maybe they're probes or worse, errors in the code. Because if the spectra hold true, Kuiper's LRDZ9 shouldn't exist. And yet it does. Precisely redshifted, impeccably massive, and radiating more enigma than light. Comparisons with other little red dots are inevitable. But what makes Kuiper's LRDZ9 feel more ominous is not just its extremity or age. It's the implication. In 2022, when the first dots appeared, we scarcely grasped their threat. In 2023, clusters offered hints, but no resolution. Now in 2025, we confront Kuiper's LRDZ9 with sharper tools, deeper spectra, and mounting dread. It is crimson. It is colossal. It is devouring the dawn on a scale that mocks time. And for a fleeting epoch in observation, it is visible enough to study before its light recedes eternally. We don't know what it is. We don't know its true genesis. But the more we probe it, the more we realize Kuiper's LRDZ9 isn't just a deep space phantom. It's a quantum riddle in flux, a shard of a narrative spanning light years and eons of veiled history. And now that narrative is illuminating us, murmuring if we dare to heed. In a cosmos governed by entropy and expanse, Kuiper's LRDZ9 is a murmur, an echo from the abyss. It did not seek scrutiny. It did not emit a beacon. It simply manifested, forged in primordial fire, shimmering with red haze, accreting slowly, and traversing our view with more anomaly than fate should permit. The James Webb Space Telescope discerned the signatures, the outflows, the quantum oddities. And what it unveiled wasn't peril in the guise of collapse or eruption. It was something profounder, subtler, a defiance of existence, a disclosure that space is not merely vast and vacant, but thrumming with quantum secrets, simulated layers, and existential weight. What if little red dots aren't just black holes? What if they're gateways? What if they're alerts? And what if James Webb didn't just detect Kuiper's LRDZ9, but unearthed a vaster verity? But the revelations don't cease there. Deeper dives into Kuiper's LRDZ9's spectrum uncover layers of quantum intrigue that border on the heretical. Its emission lines, sharp and unyielding, suggest helium abundances far exceeding Big Bang nucleosynthesis predictions. This implies reheating events, perhaps from decaying dark matter particles that quantum field theory deems unstable. Yet here they persist, fueling a black hole that grows without the usual stellar seeds. Astronomers, poring over the data, have modeled scenarios where this object acts as a natural particle accelerator, smashing protons at energies rivaling the Large Hadron Collider, but on cosmic scales. The result? Exotic particles, hypothetical axions or gravitinos, spilling into the void. These could explain the missing mass in our equations, but they also open doors to terrifying prospects, like unstable vacuum states where reality could flip, quantum tunneling us into a false vacuum collapse. The object's stability, against all odds, hints at a stabilizing force, perhaps an unknown symmetry in string theory binding the chaos. But if that symmetry breaks, the ripple could propagate, altering constants like the speed of light or electron mass. Kepler's LRD-Z9 isn't passive. It's a quantum time bomb. It's ancient light, carrying warnings of instability woven into the universe's code. Even more chilling, gravitational wave detectors like LIGO have correlated faint chirps with the object's projected location, suggesting merger events frozen in time. These waves, stretched by expansion, carry imprints of Hawking radiation, amplified beyond theory. In quantum mechanics, black holes evaporate, losing information in a paradox that haunts physicists. But Kepler's LRD-Z9's signals suggest information preservation, perhaps through holographic principles where the event horizon encodes the universe's history like a cosmic hard drive. Speculation runs wild. Could this be evidence of a simulated reality, where black holes serve as error-correcting mechanisms? In simulation theory, trending among quantum pioneers, such objects might be artifacts of computational limits, red dots marking where the rendering falters. The emotional weight hits hard. Our lives, our stars, mere data points in a grand algorithm. James Webb's infrared gaze has peeled back this layer, revealing not just an object, but a mirror to our fabricated existence. The awe mixes with fear. If simulated, who observes us? What glitch awaits? Pushing further, the object's environment teems with anomalies that fuel viral conspiracies. Surrounding gas clouds show biosignature-like traces, methane, oxygen disequilibria, that quantum chemistry says couldn't form abiotically so early. While dismissed as contamination, some theorists posit panspermia on cosmic scales, where life-seeding molecules hitch rides on quantum fluctuations across universes. Or worse, these could be technosignatures, alien megastructures harnessing black hole energy, Dyson swarms cloaked in red dust. Grounded in SETI protocols, James Webb's searches for narrow-band emissions have yielded nulls, but the broadband glow persists, echoing fast radio bursts from similar depths. These bursts, mysterious and repeating, align with black hole spins, suggesting modulated signals. The philosophical impact surges. Are we alone or watched by entities who mastered quantum gravity eons ago? Kepler's LRD-Z9, with its perfect symmetry, feels engineered, a beacon or trap in the deep. The wonder turns to dread. Discovery invites contact or invasion. As models evolve, Kepler's LRD-Z9 forces confrontations with time itself. Its light, time-dilated, shows events unfolding in slow motion, yet quantum entanglement implies instantaneous links across the expanse. Experiments with entangled photons mimic this, hinting at wormhole traversals where information leaps barriers. If this object harbors a traversable wormhole, as some string theorists propose, it could connect to parallel realities, leaking alternate physics into ours. The terror lies in the unknown. What if it's a portal for dark energy influx, accelerating expansion to a big rip? Or a black hole firewall, where quantum firewalls incinerate intruders? James Webb's observations, capturing these quantum whispers, build a narrative of interconnected fates. Our solar system, a speck in this web, feels vulnerable, exposed to cosmic secrets that could upend gravity or causality. In the end, Kuiper's LRDZ9 embodies the ultimate thriller, a hidden truth clawing into view. Its red gleam, a warning from the quantum depths, stirs fear of the unknowable, awe at the intricate, wonder at the possible. The universe, once a cold expanse, pulses with life, mystery, and peril. James Webb has not merely detected an object, it has ignited a revelation, challenging us to gaze deeper, question harder, and brace for what lurks beyond.